So I have $9,000 and I have two choices. I can invest my money to in a business or maybe in the bank for 6 months, and they're going to give me 2% interest. That's an annual interest compounded monthly. Okay, so every month it gets recalculated. Or I can be a little more patient, put my $9,000 in the bank or in my investment for 9 months, but it's a little bit lower interest rate, 1.5%. It's compounded quarterly. Now think about it. That's 4 times a year, every 3 months. Okay, so I need to put all this information together and figure out what my best deal is. All right, so let's see if you remember the formula. This is from a previous video. Total amount that you get, that's your principal with the interest added in, okay, equals the principal times 1 plus R over N to the NT power. All right, let's take a look. We've got to make sure we define our variables here. A is the total amount, including the principal and the interest. P is your starting principal. In this case, that's $9,000. Again, the 1 comes from 100%, so you're starting with 100% of the principal, and you're adding on the interest rate divided by how many times during a year it's going to be compounded. Okay, now that's all raised to the NT power. The reason why it's to the NT power is because every time we compound it, that's a multiplier effect. Okay, so it becomes an exponent. N is the number of times compounded in a year, and T is the amount of time you're investing in terms of years. So I've got to be a little careful about that. Now in the first situation, we're going to take our principal, 9,000, and we're going to put in parentheses 1 plus. Now it's 2%. Compounded monthly that means it happens 12 times a year. Okay, so 2% divided by 12 is actually 1 over 6%. Okay, we're going to do some converting here in just a second. But the exponent is NT. N, number of times compounded in a year. And 6 months is a half a year. All right, so we just have to kind of simplify this whole mess. All right, 9,000 times 1 point. Now when you do 1 over 6 and divide that out in the calculator and then move your decimal 2 places to the left, you're going to get 0.001667. Now that's a lot of digits, and actually the more digits I put in there and keep, the more accurate my answer will be. So I'm not going to do too much rounding yet. Now 12 times 1 is 12, divided by 2 is 6. So the compounding exponent on the outside is 6. Again, the shortcut is, in that time period, in 6 months, how many times is it going to be compounded? Well, it's compounded monthly, so that's going to happen 6 times. Now on your calculator, you want to do this number to the 6th power, then multiply by 9,000. Okay? If you do it out of order, you're going to actually take 9,000 and multiply it by a power of 6, and that's going to be way too big. So you're going to actually end up with, and I hope you've tried this on a piece of paper before me, $9,090 and $393. So let's call it and 39 cents. All right, so do a quick calculation on the other side. Okay, it's the same amount of money, $9,000 times 1 plus. Now your interest rate is 1.5, and you're dividing it in its quarterly, so it's 1.5 divided by 4. That's the percent. Okay, we'll have to move the decimal point over in just a minute. Now the NT, N is 9/12 of a year. Okay, and that's going to actually happen quarterly, happens 4 times a year. Okay, we just kind of have to do a little calculation out to the side, do some canceling here. So it turns out to be 9 over 3, which is 3. So that's going to happen 3 times on the outside. All right, let's simplify this mess here. It's 9,000 times. So when you divide 1.5 by 4 and you move your decimal point over and add it to the 1, I'm not really writing out all the steps here, but you're going to get 0.00375 to the third power. Okay, so it gets a little bit messy here. So do the exponent part first, 1.00375 to the third power, then multiply by 9,000, and you'll get your result of $9,101.63. All right, so the best deal, if I can be patient, is 9 months at a lower interest rate, compounded quarterly. All right, I hope you did okay.